Alright, so this is the second part of the Chapter 5 Success Guide, and we're going to go through this and take a look at the concepts. The first concept we're going to look at is explaining how energy, work, and power are related. As we've done in all the investigations in class, especially with the roller coaster, we've seen that since the transfer of energy is work, then power is the rate at which energy is transferred. That is the amount of energy transferred in a unit of time. So when we're looking at it, energy, work, and power are all related because they are all talking about just the movement of energy. Work is the movement of energy to do something useful, whereas power is looking at how fast we actually transfer that energy. You explain how to determine an object's mechanical energy. The mechanical energy is just the summation or the addition of potential energy and kinetic energy. So you add the two together and that equals your mechanical energy. Probably one of the easiest calculations you'll do. An example here would be looking at this picture from your book. As you can see, the potential energy of the basketball player down at the bottom throwing the ball is 12 joules, while the kinetic energy is 10 joules. So the total energy, or the total mechanical energy, is 22 joules. Up at the top, you can see at point B that the potential energy has gone up to 20 joules because the ball is up higher in the air. Kinetic energy has actually gone down. As you know, when you throw a ball, it actually slows down a little bit before it starts to speed back up again. So that gives it a total mechanical energy there of 22 joules as well. As you can see then, the law of conservation of energy also holds true for this situation. And we see we started with 22 joules down in the position A, and we still have 22 joules in position B. The next topic is explaining how different forms of energy are related. Now, all forms of energy can be transformed into other forms of energy. That's one of the biggest relationships between the two. The other things you can actually see is that many of them are actually related by being by all falling in the category of either kinetic energy or potential energy. They will either be one or the other. For example, thermal energy is more of a kinetic energy because we're talking about the movement of the molecules or the vibration of the molecules. We can also see in this picture here that an example of light becoming chemical, or electromagnetic in that case, becoming chemical energy for growing a carrot, electrical becoming thermal for running the stove, chemical from the ice cream cone being eaten by the cyclist to give him mechanical energy for propelling the bicycle forward, and then our cars are powered off of chemical energy, or burning gasoline, to move them forward, which is a mechanical energy in that situation. You need to be able to name and describe the two basic types of energy. As we've gone through several times, they are kinetic and potential energy. Everything falls as one of those two. You need to be able to state the law of conservation of energy, which pretty simply is nothing be created or destroyed, but the longer version is that when one form of energy is transformed into another, no energy is lost in the process. There's a few questions that we also found that are really good in the book, and I'd recommend that you take a look at them. The first ones are on page 175. Questions 1, I'll point to them up here, 1, 2, 3, 5, 6, 7, and 8 are very good on this page. On page 176, questions number 12 and 17. 12's right here. The law of conservation of energy states that. And number 17, looking at the golfer's swing. That's one that Mr. Collinger would definitely enjoy. And then question number 177, on page 177, questions number 1, 2, 3, 4, and 5. So most of the questions on this page are very good questions. These are actually similar to what you'll see on the ISTEP test too, so it's handy to take a look at these. Once again, this is the second of the podcast for the Chapter 5 quiz, and this quiz, again, is scheduled for this Wednesday on December 14th, 2011. Hopefully you found this useful, and if you have any questions or anything like that, you can jump onto either Moodle for Mr. Cora's class or onto Edmodo for Mr. Windmiller's class, and you can discuss it more with your teachers and your fellow students. Have a great day.